So looking at the chemistry standard level paper 1, obviously instructions don't open. Reminder that obviously a periodic table provided but no data sheet, and not supposed to use a calculator. So opening up, how many moles of magnesium hydroxide are produced with 0.5 moles of ammonia? So if I've got 0.5 moles of ammonia being formed, okay, so the ratio is 3 to 2. So if I got 0.5, then what we got here is 0.75 moles of magnesium hydroxide. So that's my 3 to 2 ratio. I've got 0.5 there, then divide by 2 and times by 3, 0.75. What's the sum of the integer coefficients when propene undergoes complete combustion? So what we're talking about here, balancing up the equation, got the fact that it's 3 C's, so I'm going to get 3 CO2s, 6 H's, so I'm going to get 3 H2O. One of those, I guess, then we've got 6 plus 3. So what we're talking about here is 9 O's, 4.5 of that. If I want an integer value, so it would be 2, 9, 6, 6, 12, 21, 23. What's the volume of gas when the pressure on 100 centimetre gas is changed from 400 kilopascals to 200 kilopascals at constant temperature? So PV over T, or P1V1 over T1, equals P2V2 over T2. Just using that. And we know if it's at constant temperature, therefore we can take T1 and T2 out, so therefore P1V1 equals P2V2. If then we're saying it's basically then just putting those details in, what's the volume of gas, so therefore if P1 is basically 400 kilopascals times 100 centimeters cubed of gas will equal 200 kilopascals times X, or basically take this over, so 2 times 100 equals X, 200 centimeters cubed. Okay, what's the concentration in moles per m cubed? Well, 20 grams of sodium hydroxide in 500 centimeters cubed. So the first thing we want, so concentration equals N over V. Number of moles equals M over MR. So in this case equals 20.0 over NaOH, which is 23, 24 plus 16, that's 40. So that's 0.5. So therefore concentration equals 0.5 over volume in decimeters cubed, so that's over 0.5. So that is a concentration of 1 moles per m cubed. Turning over to question 5. What is correct for 3416 S2 minus? So here we've got, there's a sulfide ion, therefore the number of protons here is 16, so it's either A, C or D. The number of neutrons, okay, take away 16 from 34, so that's 18. Neutrons 18, 18, 18, so no problem there. But electrons S2 minus, so therefore I've got 2 extra electrons, so that's 18 electrons. So it would be 16, 18, 18, which is D. Okay, which transition the hydrogen atom emits visible light? So we've got transitions here, and n equals 1, n equals 2. That transition, okay, is in the UV spectrum. So we're talking about the next one N2 to N3 being visible. Which of the following would have the same numerical value for all elements in the same period? So, if it's the same period, then obviously if it's the same period, then it's going across, but the valency electrons would be different. That'd be not the same. The same orbitals occupied. Well, it's going from S to P. But 2s2 energy subshells occupied. And highest energy levels occupied.